Okay, everybody, so what I would like you to do is take out your packets and I want you to open up to page 28. Okay, so pause me, get to page 28, and then turn me back on. Okay, so this one is asking you to integrate with bounds from -1 to 1 of 3 minus x, that quantity squared. I think the first thing that I would probably do is let's double distribute that 3 minus x. Okay, so 3 minus x times 3 minus x. All right, so that's going to give me 9 minus 6x plus x squared. All right, so I'm going to write that down here. No, actually, I'll put it up here. So it's going to be from -1 to 1, and we are going to be integrating 9 minus 6x plus x squared dx. Okay, so let's just start with the basic integration. So if we integrate 9, we're going to get 9x. If we integrate negative 6x, remember that's going to become negative 6x squared divided by 2. So that's really minus 3x squared. And then for that last one, we've just got ugly 1/3 x cubed. And we are going to be evaluating this from -1 to 1. Okay, so let me just back up and stop for a second. So we have an expression that we were integrating, in this case, this 3 minus x, that quantity squared. I don't know what that picture looks like. I kind of do, actually, but you may not know, and you're going to get functions that you don't know what the picture looks like. Okay, so we have been dealing with definite integrals, but what we had here was something that we could easily draw a graph of, and we had, like the area under the curve was maybe, a circle or a triangle, so it was easier to find the area because we could just find the area of the triangle, and that would be the integral from one bound to another. Now we don't really have that over here, so what you do is you just simplify this, okay? Then we integrate this value, which would be that. And then notice though that normally down here I would write a plus c. When we have bounds, what we call a definite integral, we don't need the plus c. Okay, so there's no need for a plus c whenever you have bounds. If you want to write that down, write that down. Okay, put that at the top of your page. Whenever we are integrating with bounds, there's no reason for us to write plus c. Okay, so then the way we do write it is once we've integrated, then we evaluate. We've done this before. And we put lower bound here, upper bound here. Okay, so now what happens after that is, the rule is we're going to do upper bound minus lower bound. And you might want to write that down also at the top of your page. Upper bound minus lower bound. So we're going to take the expression that we have right here, and we're going to plug in 1 in for every x value. That's what we're going to do first because we're doing upper bound first. Okay, so I'm going to open a set of parentheses, and I'm going to do 9 times 1, which is 9, minus 3 times 1 squared, which I know is 3, plus, and then 1/3 1 cubed. Well, I know 1 cubed is 1, so that would just be 1/3, right? Okay, so there is, everything here is worked out according to putting 1 in for all my x values. Okay, now what I'm going to do is, remember the rule is subtract. So upper bound minus, now I'm going to plug in the lower bound. So in other words, now I'm going to put in -1 in here, here, and here. So when I put -1 in here, do you see that changes that to a -9? So I've got -9. Now when I put in -1 here, that doesn't change anything because when I square it, it still becomes positive. Okay, so that's still going to be -3. And then -1 when I cube it is going to be a -1 times that 1/3 will be a -1/3. Okay, so I'm going to do a little bit of simplifying here. So I'm going to, in the parentheses, write 6 because 9 minus 3, plus 1/3, okay, minus, and then in the second set of parentheses, I've got negative 12 minus 1/3, okay. And then at that point, I'm going to distribute this negative through, and then I'll go from there, all right? Okay, so then I've got 6 plus 1/3, that's going to be plus 12, and then plus 1/3, okay, which is 18 plus 2/3, which really is 18 and 2/3. And then to simplify this, remember we multiply these two numbers, okay, so that would be 54 plus 2 more, and that would give me 56/3, okay? So final answer is 56/3. And there's your answer. Now let's just stop and think for a second. A couple of things. So what you really found was the area under this curve if we were just looking between -1 and 1. And again, because we really aren't sure what this thing looks like, and it's not, you know, in the shape of an area that we're familiar with regards to knowing a formula like a triangle or a trapezoid or a circle, this is how we handle that. So we integrate. When we have bounds, there's no plus c, and we do upper bound minus lower bound, and that's what we did here, upper bound minus lower bound, and then we just work it all out. Now if you wanted to here, you could have made a common denominator so you don't have to take this mixed number and change it here, but I don't think it really matters. All right, let's go to number 2. All right, so number 2, same deal. So I am going to integrate that, so that's going to be 2x to the 2/3. Well, I have to add, hold on, let me get my marker going here. I have to add 3/3 to that, right? Okay, so that's going to be x to the 5/3. I've got the 2 in front there, and then I have to divide by 5/3, which is really multiplying by 3/5, right? No plus c. And then I am going to evaluate that from 1 to 8. Now that looks super ugly, so I'm going to change that a little bit. And that's going to become 6/5 x to the 5/3, and we're going to evaluate that from 1 to 8. That looks a little bit better. Okay, I'm going to actually go one step further. When you have constants, like we do here, we have this 6/5, and we're evaluating, that can get a little ugly. So the nice thing about integration is when we have a constant, you can pull that constant out. So I would leave that thing out there. And now, watch what I'm going to do. Upper bound minus lower bound. Okay? That way the 6/5 won't complicate anything. We'll deal with it at the end. All right, so just keep bringing it down though. So we got 6/5. Okay, now remember what we have here is we have the cube root of 8, which is 2, and then 2 to the 5th power, which is going to give us 32, minus, and then I technically have the same thing here, the cube root of 1, which is 1, and then 1 to the 5th power, which is still 1, so that'll be 1. Okay, so now here's where the 6/5 kind of comes back. So now that we've simplified the parentheses to 31, now we can go ahead and multiply that. Remember, this is over 1. Okay, so that's 1/86/5, and your answer is A. All right, make sure that you're writing all this down in your notes packet. All right, let's do number 3. So number 3, same deal again. A little bit easier in some senses, maybe not so much in others because you might not know your trig facts, but the integral of cosine, hopefully you remember, is sine. We don't need the plus c. We're just going to go right ahead and evaluate that from pi over 3, remember that's 60 degrees, to pi over 2, remember that's 90 degrees. Okay, so then we're going to do upper bound, so sine of pi over 2, minus your lower bound, which is the sine of pi over 3. Okay, pi over 2, the sine of that is 1, minus the sine of pi over 3, which is 60 degrees. That's radical 3 over 2. Okay, so you could really write this as 2 over 2 minus radical 3 over 2. I think that might help a little bit. Okay, and then you can see that that answer, hopefully you can see that that answer is A. Okay, because I can rewrite this as one fraction with its denominator. Okay. Alrighty, go ahead and turn the page and let's look at 1990 AP1. Now this is going to be a combo of things here and a little bit of review. So it says a particle initially at rest. Remember, if something is at rest initially, that means at time 0, the velocity is 0. If something is at rest, the velocity is 0. And that word initially means at time 0. Okay? All right, so we're going to need to know that. They gave us an equation for the acceleration, and they gave us some other stuff down here that we'll deal with in a second. But they want us to find the values of t for which the particle is at rest. So we need the velocity equation. So if I need the velocity equation and I have the acceleration equation, then obviously I need to integrate. Okay, now if you want to stop me and try that, go for it. And then you can turn me back on. All right, so I am going to get the velocity, I'm going to integrate 12t squared minus 4dt. All right, so that is going to give me 4t cubed minus 4t. Now there are no bounds, so I have plus c, right? And, oops, that would be the velocity equation, right? I'm squeezing that in there, sorry. Okay, now let's go back to the fact that they gave us that v of 0 is equal to 0. So I'm going to plug in 0 for t, and I'm going to set it equal to 0. Okay, so setting it equal to 0 and plugging in 0 for t. So that would give me, actually, whoops, that would give me 0 there, minus another 0 equals c. So you can see, obviously, that c is 0. So that means that your velocity equation is 4t cubed minus 4t. Okay, now that's not what they asked for, but we need that in order to answer the question for part A. It says to find out when the particle is at rest. Well, the particle is at rest when the velocity is equal to 0. So now we can kind of go through and let's factor out a t and a 4, and that's going to give me t squared minus 1. So we have t equals 0 here on the right, and then I hope you can see that t would equal plus or minus 1 over here. I'm sorry, this is on the left, okay, and this equals plus or minus 1. But be careful, because time has to be greater than or equal to 0, so we can't have that negative value. Okay, so our final answer for that one, it's just going to be t equals 0 and t equals 1. Those are your final answers. Okay? All right, part B wants you to write an expression for the position. So we're going to kind of do what we just did, but we are going to now integrate the velocity equation, which actually, remember, c will be 0, so really that won't be there. Okay, so to find the position equation, we are going to integrate 4t cubed minus 4t dt. All right, so your x of t is going to be equal to t to the 4th minus, and then this is going to be 2t squared plus c. Okay, now let's look and see. They did give us a set of values right here. X of 1 is equal to 3, so I'm going to set this equal to 3, and I'm going to plug in 1 in both of those spots for the t. Okay, all right, so then I am going to have 3 equals here, and then I'll have 1 minus 2 plus c, so then c would be equal to 4. And my x of t equation would be t to the fourth minus 4t, minus 2t squared, and then plus 4. Okay, and there is my position equation. All right, part C wants total distance. Okay, so remember, for total distance, we always use the values that they gave us, which is 0 and also 2. Okay, but then we look for where the velocity would be equal to 0 between these two x values, and the velocity is equal to 0 at these two spots. So we need t equals 1 as one of our values here. Okay, so what you're going to do, remember, is you're going to plug these values in, 0, 1, and 2, right back in here, and get the y value. So we're going to get 4 when we plug in 0. We're going to get 3 when we plug in 1. You're going to have to work this out on your own. And 12 here. So the distance from 4 to 3 is a distance of 1. And from 3 to 12 is a distance of 9. So altogether, your total distance is going to be 10. Make sure you're taking notes on all of this. All right, so let's look at the one below it. Part A wants you to find each x value such that the line tangent to the graph of f, aka f prime, is horizontal. Tangent to the graph of f means f prime is horizontal. Remember, if you have something that's horizontal, it's a zero slope. So we're looking essentially where the derivative, f prime, is equal to 0. That's really what that's saying. F prime equals 0. Line tangent to the graph, there's your f prime. Horizontal, there's your 0. Okay. So we are going to start with f double prime, because that's what we have, and we're going to integrate it to get f prime. So f prime is going to be equal to the integral of 24x minus 18 dx. Okay, so f prime of x be equal to, and that'll be 12x squared minus 18x plus c. Now let's look for a set of conditions. As far as the derivative is concerned, we know x will be 1, and we'll set it equal to -6. That'll help us find our c. So we're going to put -6 here, and we're plugging in 1 for x. Okay, and so then when we work this out, c is 0. So our f prime of x is equal to 12x squared minus 18x. Okay, now let's make sure we read the question. We want to find out where the derivative is equal to 0. Well, we found the derivative, but we now have to set it equal to 0. Okay, so we're going to set that equal to 0. Let's factor out a 6x. We get 2x. Sorry, that is really messy. Equals 0. So here we have x equals 0, and over here we have x equals 3/2. And those are our two values. Okay, all right, part B just wants an expression for f of x. So we are going to take our f prime of x, which is right here, and we're going to integrate that. So we're going to integrate 12x squared minus 18x dx. All right, so let's see what we get. So we get 4x cubed minus 9x squared. What is happening to my minus there? Plus c. Okay, and then this is going to be our position equation, so that's x of t. And they gave us a position value right here, so I'm going to set this equal to 0, and I'm going to plug in 2 for my x values. So that's going to give me 32 minus 36 plus c. So you can see c is going to be 4. Okay, and I don't know why I called that x of t. That should be f of x. So then we're going to have f of x equals 4x cubed minus 9x squared. And then, like I said, our c is 4, so that'll be plus 4. And there's your answer for part B. Okay, let's skip part C. We have not done average value yet, so you can just cross that out for now. We will do it, but not yet. Alrighty, so part A asks you to find the velocity, and we have an acceleration equation. So to find the velocity, we are going to integrate 6t plus 6 dt. Okay, so then we're going to get v of t equals, that's going to be 3t squared plus 6t plus c. Now let's see, they did give us a set of conditions here. They told us at time 0, the velocity is negative 9. So we're going to plug in 0 for t and set it equal to negative 9. So negative 9 equals c, right? Because we're plugging in 0 for all of those t values. All right, so then we've got v of t equals 3t squared plus 6t minus 9. And that's what they want for part A. Okay, part B. When is the particle moving to the right? Well, hopefully you remember that that would be when the velocity is negative. So we're going to take that velocity and we're going to set it equal to 0. So we're going to write 3t squared plus 6t minus 9. Let's set it equal to 0. I'm going to do a sign chart. So I'm going to take that 3. Actually, you know what? I'm going to divide out that 3. Okay? I like that better. So we're going to get t squared plus 2t minus 3 equals 0. So that will be t plus 3 and t minus 1 equals 0. So when I do a sign chart for the velocity, you can plug in values. You're going to get plus minus plus. And it says, when is it moving to the right? Now just be a little careful here. This is time. Even though it's moving to the right here, we can't have negative time here. So then the only values that will make sense for this particular question would just be when time is greater than 1. Okay, so when the time is greater than 1, the velocity is moving to the right. And you would say because the velocity is positive during that interval. Okay? All right. Last part. So we have to find the position. Well, we're going to just take that velocity and we are going to integrate it. So we're going to integrate 3t squared plus 6t minus 9 dt. And this is going to be our position equation. Okay? So when I integrate that, I'm going to get my position is equal to t cubed plus 3t squared minus 9t plus c. Okay, now let's see what they gave us as far as a set of conditions. At time 0, its position is negative 27. Okay, so t is 0, and I'm going to set this equal to negative 27. So when t is 0, all of this stuff is going to just disappear, right? So do you see that your c is going to be negative 27? So then your final position equation is going to be t cubed plus 3t squared minus 9t and then minus 27. Okay, make sure you're getting all this down in your notes. There's your answer. That's all she wrote.